Alright, so lesson 7.1. When I look at it, this is all about arithmetic sequences. It tends to be pretty easy. You just got to be able to follow along and try to understand what all the different terminology is. So what is an arithmetic sequence? An arithmetic sequence is a sequence of numbers in which the difference between any consecutive terms is the same. Now, basically, I like to summarize this a little easier and say it's a sequence that adds the same amount each time, right? And when I look at a sequence, if I take like 3, 8, 13, 18, right? This is an arithmetic sequence because to get to the next term, what am I doing each time? Adding 5. Now they say where the difference between any two numbers, right, is the same. So they're basically saying 8 minus 3 is 5, 13 minus 8 is 5, 18 minus 13 is 5, right? So that's how you determine if it's an arithmetic sequence. Okay, now the amount, right, the common difference, all right, is the constant value d between any two consecutive numbers in the sequence, right? So basically it is the amount added each time. Okay, so up above your common difference would be 5. So if I gave you this one, 2, 5, 8, 11, right? How much am I going up each time? I'm going up 3. So my common difference, right, would be 3. If I was subtracting 3 each time, it would be negative 3. Okay, when you see this symbol, right, a sub 1, that's red, a sub 1, right, it's basically telling you the first term in the sequence. So if I had to take this sequence up here, I would say a sub 1 is 2. Now, if I wanted to say what a sub 2 is, that would be the second term in the sequence, which would be 5. Okay, so that's just a way we identify the number term we are in the sequence. All right, now the recursive formula. There's two parts of this, right? The first part is identifying, right, the first term. So we first say a sub 1 equals the first term, and we would identify that. Okay, now when we talk about recursive, it's like, what are we doing to the first or to the previous term, right? So what we say is, right, a sub n then is a sub n minus 1, right? And then what are we doing to the previous term each time? We're adding that common difference d. Okay, so this represents previous term. This represents your common difference. Okay, now, for instance, right, if I give you, actually we'll just explain it more through the examples further on. The explicit rule, right, is basically no different than your point-slope form, we're going to say. It's your point-slope form. And the reason I say this is because an arithmetic sequence represents a linear function. So when we talk about the explicit rule, the way this text does it is they say a sub n is equal to a sub 1 plus, they say n minus 1 times d, right? I actually like to see it a sub n equals your common difference times n minus 1 plus your first term. Okay, and we'll talk about that a little more in an example, right? This mocks your point slope form a little more closely, right? Because d acts as your slope. So the term of an arithmetic sequence is a number or item that represents a specific position in a sequence. Alright, so if you have to pause the video, write those down, go ahead. So now when we talk about the main ideas of this, an arithmetic sequence is a number pattern in which the difference between any two consecutive numbers is constant. right? That constant is called the common difference. So how do we go about working with arithmetic sequences? First thing is we got to find the common difference, right? What are we adding each time, right? How do we do that? We choose one number in the sequence and subtract the number just before it, right? So when I look at this, right, what they're saying is if I take the next term in the sequence, 12, and I subtract the previous, I get 6. If I take 18 and subtract the previous 12, what do I get? 6. I recognize it by I'm going up 6 each time. So I would say the common difference is 6. Alright, either way you look at it, you get the same answer. Okay, so when all pair of consecutive terms in a sequence share a, right, what do we put here? That's going to be a common difference, right? The sequence is an arithmetic sequence. Okay? So now determine if the following sequences are arithmetic, right? And determine if there's a common difference. If I look here, what am I going up? I'm going up 2, up 2, up 2, up 2. Is there a common difference? Yes, that common difference is 2. So is it arithmetic? Yes, you're adding the same amount each time. When I look at the next one, I go up 2, I go up 2, I go up 3, and then I go up 6. Is there a common difference here? No, right? The up 3 and up 6 ruin it. Therefore, it is not arithmetic. The next one, I look at all of them, right? I go up 4, up 4, up 4, up 4. Is there a common difference? Yes, 4. Is it arithmetic? Yes, right? Because it has a common difference. Okay? So, can you write an arithmetic sequence with a recursive formula? Okay? Now, this is where it's going to get a little tricky, right? So, first off, let's review what the recursive formula says again. So a sub n is the value of the very first term in the sequence. Then a sub n minus 1 is the value of the previous term in the sequence. And d is your common difference. Okay? So let's look at this, right? What is the fifth term in the sequence below, right? What am I doing each time here, right? So I look for my common difference and I notice if I do 270 minus 255, right, what do I get? 15. So I go up 15, up 15, up 15. So my common difference here is 15. Okay? So now, if I look at it, if the fourth term, right, if this is your first term, your second term, your third term, your fourth term, if I want to find the fifth term, what am I going to do to the fourth term? I'm going to add 15. So the fifth term, and we display that as a sub 5, would just be the 300 plus your common difference of 15, which give you 315. Okay? Now another way to look at it, right, and I'm going to show you here, is when I look at the next one, right, it says, what is the seventh term, right? So I go ahead and I see if there's a common difference. From negative 11 to negative 4, I go up 7. From negative 4 to 3, I go up 7. I go up 7. So right away, my common difference is 7. Remember, if you were going down, you would have negative, all right? So the next one, we're looking for a sub 6, right? I know that's going to be a sub n minus 1 plus my common difference, right? And the reason I'm going to do it this way is to help make sense of the next rule, right? You should know right away you're going to go up 7, so your seventh term is just going to be 31. But I want you to look at it this way. If I'm looking for the sixth term, I'm going to do the seventh term, right? I'm going to do a sub 7 equals, if n is 7, I'm going to look for a sub 7 minus 1 plus my common difference. So that would give me a sub 7 equals a sub 6, right? Because 7 minus 1 is a sub 6 plus my common difference d. And right away here, if I look, what is the sixth term of the sequence? 24 plus what is my common difference? 7, and that would give me 31. So the seventh term would be 31. Okay. So, for the next part, the explicit rule, right? A sub n equals, right, the value of the nth term in any sequence, right? So we look at a sub 1, again, that is going to represent the first term in the sequence. N is going to be any term, right, position in the sequence. And D, again, is your common difference. Okay? So with this, use the explicit formula to solve each problem, right? Show your work. So, if the first term of a sequence, in an arithmetic sequence, is 3, so your first term is 3, and the common difference, D, is 7. What is the value of the 10th term? Well, right away, if I write my formula, A sub n equals, right, A sub 1 plus D times n minus 1. Okay? So what I'm going to do here is say, I'm looking for what term? The 10th term. So right there that tells me n is 10. So I'm going to take, right, the a sub 1, or my first term, 3, plus my common difference, 7, times 10 minus 1. And what this gives me, if I evaluate it, I'm going to do 3 plus 7 times 9, which gives me 3 plus 63, which ends up being 66. Alright, so again, these formulas are completely different from each other, but both of them use the first term and common difference differently. So when I look at the next one, what is my first term? This here is my a sub 1, so that is 5. What is my common difference? Oh, what am I going up each time? I'm going up 2 each time. So, a sub n equals a sub 1 plus my common difference times n minus 1. So if I'm looking for the 100th term in this sequence, I'm looking for a sub 100. And if I take my first term, 5, plus my common difference, 2 times 100 minus 1, that's going to give me a sub 100 equals 5 plus 2 times 99, which gives me 5 plus 99 times 2 is going to give me 198. And 5 plus 198 is 203. Okay, so this is how we use the explicit rule. Alright, now how can you tell the difference between the two? Well, if I look here, right, this is a recursive rule because it's taking the first term and it's showing you what you're doing to the previous term each time. So how do we use this? Well, right away I can get the first term from this is 11, and I know what I'm doing each time is my common difference, which happens to be minus 2. Okay, so when I look at my explicit rule, right, remember it's a sub 1 plus d times n minus 1. So a sub n equals, what's my first term? 11 plus, in this case that could be plus, since d is negative 2, it's going to be minus 2 times, right, n minus 1. This would be your explicit rule. Now when we look at it, this here, right, is your explicit rule. where this right here is your a sub 1. See, they put the common difference over here, but that is your common difference d. So if I had to write the recursive rule, I need to state the first term, which is negative 5. Right? Now, once I see that, I say a sub n equals my previous term, a sub n minus 1. And what am I doing to that each time? Since my common difference is 3, I'm adding 3 to it each time. Okay, so these two statements together is the recursive rule. Alright, so when we look at 7.1 checkup, right? First set of problems, find the common difference between the terms of the arithmetic series, right? Or sequence. So, right away here, what am I seeing is happening each time here? Well, this goes up 5, this goes up 5, up 5, up 5. So my common difference d is 5. Now when I look at the next one, right, am I going up or down each time here, right? In this case, I'm going down. Okay, so what am I going down here, right? If I look, I'm going down 9, going down 9, going down 9, and if you see, I'm doing it negative 9. So my common difference here is negative 9. Okay, so if I have to write the next few terms of the arithmetic sequence, I look here, I'm going down 4, I'm going down 4, right? If I go down 4 again, where am I going to land? 3, so I would do 7 minus 4, and then here I'm going to do 3 minus 4, which would give me negative 1. Okay? Now, for the recursive formula, and please pay attention to this, the first thing we have to do is identify the first term. A sub 1 is equal to what? What is the first term in my sequence? That is a sub 1. So, when I look at this now, what we say is, we say every term after that, a sub n, is the previous term, and this will always be a sub n minus 1. Always. That represents the previous term. And what am I doing to the previous term each time? Well, what's my common difference here? My common difference d is 4. So what am I going to do to the previous term to get to the next term? I'm going to add 4. Okay? So remember, what if 5 is the previous term, what did I do to 5 to get 9? Right? Added 4. What did I do to my previous term, 9, to get 13? I add 4. So you got to remember, right? This represents your first term. This represents what you're doing to your previous term. Okay? Number 5. What is the explicit rule for the arithmetic sequence? Right? First, if I look, my a sub 1 is 3. So my first term is 3. And my common difference, if I notice, is it's going up 6. So my common difference d is 6. So remember this formula, a sub n equals, right? We're going to say a sub 1 plus my common difference times n minus 1. So a sub n equals, what was my first term? 3 plus, what was my common difference? 6 times n minus 1. And that would be your explicit rule for this sequence. So right now, in the explicit formula for arithmetic sequence is, so if they give you this as your explicit rule, what is the 200th term? What they're basically saying is, if n is 200, we're going to plug that value in here. So, a sub 200 is equal to 20 plus 200 minus 1 times 2. So if I use my order of operations, a sub 200 is 20 plus 199 times 2. And remember, order of operations tells us we have to do multiplication first. So 199 times 2 gives me 398. So a sub 200 equals 20 plus 398, which is going to give me 418. Okay, so the 200th term would be 418. So, for questions 7 and 8, Alright, in the seating for a concert, the first row has 10 chairs. Every row after has 2 more chairs. So right away, what is my first term going to be? 10. Then every row after that has 2, which means I'm going to add 2 each time, so my common difference is 2. So the explicit rule, remember we're using a sub n equals a sub 1 plus my common difference times n minus 1. So a sub n equals, what was my first term? 10 plus, what was my common difference? 2 times n minus 1. Okay, so how many chairs would be in row 20? Well, a sub 20, right? I'm replacing n with 20. So 10 plus 2 times 20 minus 1, which is going to give me 10 plus 2 times 19, which is 10 plus 38. So a sub 20 is 48 chairs. Okay. Alright, number 9. An arithmetic sequence has the explicit rule given. What is the recursive formula? So remember, in this explicit rule, this is the explicit. This 14 is your first term, and 3 is your common difference, right? So now that we know that, right, to write our recursive rule, what's our first term? So remember, we have to have 2 expressions here. So my first term is 14, so that's the first part of my recursive formula. Then we say a sub n is equal to my previous term, a sub n minus 1. What am I doing each time? I'm adding 3, so it would be this. And this would be your recursive rule. Okay? And now, number 10, if you're given the recursive rule, you know a sub 1. What is the explicit rule? Now I need my common difference. So my common difference is negative 3. So my explicit rule, a sub n equals my first term, 42. Since my common difference is negative, I'm going to go minus 3 times n minus 1. And this would be your explicit rule. Okay? So that should be pretty good to give you a good idea how to do the quiz. Go ahead and do that and then text me your scores.